All right. Give me just a sec. All right, here we go. Ladies and gentlemen, could it be? This is the finale of the ITM Happy Hour, and I am always your host, Richard Beamer. I'm sure my information technology wisdom will be missed, and of course, I wish I could say I'd miss you all, but who are we kidding? This week on the ITM Happy Hour, we're covering one of the most fascinating and broad topics of the semester, which is data analytics. Before we go anywhere, let's start off with a little bit of comedy. We've got an executive and a data analyst, and the executive says, use the CRS database to size the market. That data is wrong. Then use the SIBS database. That data is also wrong. Well, can you average them? Sure, I can multiply them too. I think this is kind of funny. It just kind of goes to show how data is oftentimes viewed as the capital T truth, but oftentimes it's just wrong and all over the place, and you're really not able to draw conclusions all the time. But I thought it was a bit comical. So, looking ahead to the rest of this titillating presentation, we'll be covering an introduction to data analytics and its connection to big data. We'll even touch on a brief history of data analytics, varying categories of data analytics, the different benefits and concerns associated with data analytics and big data, then practical or real life uses, and then we'll even do a quick recap at the end of the presentation. As we broach this topic, it's important to remember how it blends with big data and data storage as well. I'd like to rehash that, especially based on the previous presentations that I've prepared for the ITM Happy Hour. So for starters, let's get on the same page so we're talking about the same thing. According to Wikipedia, data analytics is the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information, suggesting conclusions, and supporting decision-making. In other words, it is taking information in the form of data and making sense of it all. But of course, the modern-day process of data analytics only exists due to the presence of and access to big data. Now, let's move on to the timeline. For a brief warning, the history of data analytics is quite dense, so this portion of the presentation will be a bit more bulky. So to start off with the history of data analytics, we need to remember that data analytics is very much dependent on statistics. According to Fly Data, people generally agree that the beginning of statistics in the form of big data started around the era of ancient Egypt, around 2600 BC, when Egypt was taking a periodic census for building pyramids. Jumping ahead to 2400 BC, the abacus, a device for calculating, is used, and with the first libraries being erected, we see mankind's first attempts at mass data storage. Now, scooting way along to 1663, we meet John Grant, who conducted one of the first recorded experiments in statistical data. He believed he could create a warning system for the bubonic plague as the perception of and the vernacular around statistics changed. The term business intelligence was coined by Richard Miller Devins in the Encyclopedia of Commercial and Business Anecdotes to describe a blending of statistics and the business strategy. And then in 1880, we see the U.S. Census Bureau run into a situation. At that point in time, it became evident that it'd take longer to collect and synthesize data than an actual 10-year census cycle, for each cycle, that is. So in 1881, Herman Hollerith created the Hollerith tabulating machine to reduce the data generation time from 10 years to 3 months, from 10 years to 3 months. The company that he founded later actually became later known as IBM. So he did something pretty cool there. Statistics are continued to be used here and there. Then in the mid-20th century, we witnessed the advent of large data centers, like in 1965, when the U.S. government planned and built the world's first data center to store hundreds of millions of tax returns and fingerprint sets. And then in 1976, the processes and make day-to-day work more efficient. And in 1997, Google allows us to surf the web a massive depot for information, and presents us with endless links for us to analyze. 2014, more people are using their cell phones to tap into digital data rather than home or office computers, and 88% of business executives interviewed by GE stated data analytics is a top priority for their business. Clearly, its history is vast, and we could spend eons trying to get caught up to date, but this timeline demonstrates how rapidly everything data analytics or big data related changes. So now that we know what data analytics is and have an understanding of its expansive history, let's break it down. We have three primary categories to consider: business intelligence, exploratory data analysis, and confirmatory data analysis. Business intelligence is the tech-driven process for looking at data and using it to draw conclusions and help business executives or managers make business decisions. For example, if a data system tells a sandwich shop manager that one sandwich only sells 5 per month and all the others sell 50 per month, maybe it isn't worth keeping that sandwich on the menu. Next, exploratory data analysis looks to find patterns and relationships in data. So it is really identifying variables and drawing relationships based on collected data. We could compare how varying holiday seasons influence breakup rates among couples, even, or something like that. And then finally, we have confirmatory data analysis. This is defined as statistical techniques to determine whether hypotheses about a data set are true or false. This could be exemplified by a doctor assuming that people who receive flu shots in September are more likely not to get sick than people who receive flu shots in November. Assumably, giving your immune system more time to prepare for the virus would decrease your likelihood of getting sick, and data collection could be used for a confirmatory data analysis. Of course, this technology could be instrumental for so many people, organizations, or companies, and some benefits to consider are: one, improved operational efficiency. With this sort of technology, you can identify new revenues, streams, or gain a competitive advantage. Then you also have predictive and prescriptive modeling. And with this, you help yourself become your own fortune teller. You can prepare for potential or imminent situations and be ready to act in the future. But of course, there are many legitimate concerns to address as well. As more data is collected, the more likely it is that your own data is not only used, but used without consent. Then with great data comes great responsibility. Data analytics and its ability to harness big data provides individuals with superior amounts of knowledge, not held by the common public. Some would say that they're responsible for how they use it, or don't even. And then three, on top of everything, nothing is foolproof, and even comprehensive data analytics can produce inaccurate or unwanted conclusions. So finally, let's go ahead and consider some of the concrete real-life examples. Just to name a few, Aetna is currently using data to develop methods of identifying diabetes earlier so it can be diagnosed and treated earlier. The ASCO, or American Society of Clinical Oncology, is using big data to find best treatments for cancer. Then cities can even use big data to determine how to time traffic lights at different times of the day to relieve traffic congestion. Even in 2012, in the 2012 presidential election with Barack Obama and Mitt Romney, big data and data analytics were used to identify key states and key voters who are capable of greatly influencing the election. All in all, data analytics has incredible potential with a rich history, rooted in the incredible propensity of mankind to seek a greater understanding of the world. Thank you. Here are my sources, and I am out. Thank you very much.